Welcome to the Crash Modification Factors video for the Missouri Department of Transportation. This video corresponds with MoDOT Engineering Policy Guide 905.3.6.2.8. Key takeaways from this video include: what are crash modification factors? Best practices for selecting crash modification factors, and how to apply crash modification factors. Let's begin with an introduction of this video. What is a CMF? CMF stands for Crash Modification Factor. As defined by the Highway Safety Manual, it is an index of how much crash experience is expected to change following a modification in design or traffic control. Thus, CMFs are values used to determine the predicted change in the number of crashes from implementing a chosen countermeasure. Crash modification factors can play an important role in a traffic safety benefit-cost analysis to determine the anticipated benefits of a countermeasure. A CMF value of less than 1 reflects a predicted reduction in crashes, while a CMF value of greater than 1 reflects a predicted increase in crashes. A CMF value of 1 suggests that the countermeasure is expected to have no impact on the number of crashes. The use of CMFs is consistent with the information contained in the Highway Safety Manual. As referenced in MoDOT's Safety Handbook for Locals, EPG 907.5, one of the most accepted methods of assessing safety at a location is through the analysis of existing crash patterns to include frequency and severity. This information is obtained through the crash analysis summaries, crash reports provided by law enforcement, and collision diagrams. Analysis of this information allows the examiner to determine appropriate countermeasures or safety treatments intended to mitigate crash patterns. One or more countermeasures may be proposed in order to alleviate the existing crash patterns at the location. Countermeasure selections should be vetted through a project core team. This will allow MoDOT to better maintain countermeasure selection and track historical performance. Once possible countermeasures are selected, the responsible party should determine the appropriate crash modification factors to apply to the analysis. Now that we know what crash modification factors, or CMFs for short, are, let's discuss how to select a CMF. Step 1 is to contact the MoDOT Project Core Team and Central Office MoDOT staff for the approved CMF list. MoDOT recognizes this is not an all-inclusive list and that new research on countermeasures is continuously being released. If MoDOT does not currently have the appropriate CMF on their approved list, they may recommend the use of the Federal Highway Administration funded CMF Clearinghouse, www.cmfclearinghouse.org. This site provides an online searchable database to find applicable countermeasures and the published CMFs established for each. As with countermeasure selection, CMF selection should be vetted through the project core team prior to using. Each countermeasure within the CMF clearinghouse is assigned a star quality rating between 1 and 5, with 5 representing the best rating to indicate the confidence in the results of the study that produced the CMF. The rating is based on several factors, including design of the study, sample size, data source, standard error, and potential biases. The clearinghouse also assigns star quality ratings for CMFs provided in the Highway Safety Manual. Due to the extensive size of the CMF Clearinghouse database, a search for CMFs will often return many results even when using the filtered search feature. Therefore, users will often need to use professional judgment to decide which is the best CMF to use. MoDOT guidance is to select the CMF with the best quality rating for conditions as similar to the project area as possible. The analyst should coordinate with MoDOT or the project core team for concurrence on their CMF selection approach. Star quality rating. The star quality rating indicates the quality of the CMF, with 5 being the highest quality rating as mentioned earlier. The star quality rating can be used to help determine the most appropriate CMF to use if all major factors are similar. Score details. The clearinghouse assigns scores of excellent, fair, or poor for each rating categories. Detail on the scores can be found within the star rating on many of the CMFs. This information is helpful when comparing the results of 2 or more comparable CMFs. Similarity in locality of data. Information related to the specific geographic region that the CMF was developed is provided for the user. It is preferable to use the data based on similar topography, weather, and other factors if possible. Traffic volume range. A range of traffic volumes used in the CMF development is provided for the user to select the most applicable CMF. It is at the analyst's discretion whether to allow for going out of range if no other CMF is applicable. Age of data. All studies for the CMFs provide a date range for the study performed. The CMF that uses the more recent date range is preferred if all other factors are similar. Original study report. The clearinghouse provides a link to the study report if it's available. This is often helpful to the user to gain insight on the study background. CMFs are useful tools in the estimation of predicted impacts to crash reductions and/or increases. They can be applied to different crash attributes such as crash type, crash severity, or total crashes. Due to the variability in location characteristics, driver behavior, and other factors, actual reduction in crashes will vary. The standard error listed for each CMF is helpful in determining the anticipated effectiveness of a countermeasure. When selecting CMFs, consider this guidance from the CMF Clearinghouse. CMFs that most accurately reflect the characteristics of the location being investigated are the most appropriate. More than one CMF may be applicable. Use the CMF with the highest star rating, making sure that it is applicable to the proposed countermeasure and study location. If all factors above are equal, then the more conservative value should be selected. If there is no applicable CMF, contact the project core team for further guidance. Now that we have defined crash modification factors and some best practices for selecting them, let's discuss how they are applied. Once CMFs are determined, they are multiplied by the appropriate crash information. For example, number of crashes, severity, types, etc., as indicated by the CMF. Many CMFs will apply to all crashes, but some CMFs specifically apply to a particular crash type. For example, rear ends or crash severity, such as fatal and serious injury crashes. For predictive analysis, which is the recommended approach, the CMFs are multiplied by the predicted crash information to estimate the predicted number of crashes as a result of the improvement. This can then be converted to expected crashes using HSM methodology as outlined in EPG 905.3.6.2.7. If predicted crash analysis is not possible, the CMFs are multiplied by the crash information as revealed in the crash history at the location. While not the preferred approach, this calculation provides a sense of the anticipated number of crashes as a result of the proposed countermeasure. It is generally preferable to use a single CMF. However, it is also common for traffic professionals to recommend multiple countermeasures to address crash patterns at a location. In order to accurately capture impacts for these types of situations, multiple CMFs with the same crash type, crash severity, and area type may be combined. If countermeasures are mutually exclusive to one another, then combining may not be necessary and they can be applied separately. While multiplication of CMFs is an acceptable practice, it is undetermined if implementation of more than one countermeasure at a location will provide the full effect of crash reductions compared to countermeasures implemented individually. This overestimation of crash reductions grows more uncertain with the addition of more countermeasures at a given location. As a result, judgment should be applied when multiple countermeasures are proposed, and MoDOT recommends capping the number of CMFs that are used to a maximum of 3. Now, let's discuss key takeaways and additional resources. The revisited key takeaways from this module include: what are crash modification factors? Best practices for selecting crash modification factors, and how to apply crash modification factors. Additional information can be found in MoDOT EPG articles and the Federal Highway Administration funded CMF Clearinghouse. Time to see what you know. Please be aware that the quiz is designed to help reinforce module concepts and is not used to validate completion of the module. Question 1. What are crash modification factors? A. The predicted number of crashes. B. Values used to determine the existing number of crashes at a particular location. C. Values used to determine the predicted change in crashes from implementing a chosen countermeasure. Or D. None of the above. The correct answer is C. Crash modification factors are values used to determine the predicted change in crashes from implementing a chosen countermeasure. Question 2. A CMF value of less than 1 reflects a predicted what in crashes, while a CMF value of greater than 1 reflects a predicted what? A. Increase, reduction. B. Reduction, increase. The correct answer is B. A CMF value of less than 1 reflects a predicted reduction in crashes, while a CMF value of greater than 1 reflects a predicted increase in crashes. Question 3. True or false? MoDOT guidance is to select the CMF with the best quality rating for conditions as similar to the project area as possible. The correct answer is true. The analyst should also coordinate with MoDOT or the project core team for concurrence on their CMF selection approach, as there may be situations where a highly rated CMF may not be the most appropriate for the particular project. Thank you for participating in the TIA Guidance Crash Modification Factors module. MoDOT encourages you to view the other TIA Guidance Learning modules. If you have any questions, please reach out to MoDOT Central Office Highway Safety and Traffic.